talking about eye tracking data today. What is eye tracking data, how we can use it, and why should we look at it? So first of all, what is eye tracking data? Here we're going to look at where does eye tracking data come from. I don't assume everyone to have worked with it already. What does this data look like, and what do we use, and how do we analyze it? Where does this data come from? Here you see two pictures. They're both two different kinds of eye trackers. To the left, you see me making a funny face while wearing a mobile eye tracker. And to the right is a desktop eye tracker. The desktop eye tracker is placed under a computer screen, and it records eye movements while you're doing tasks on the computer. The mobile eye tracker gives you the flexibility to move around in everyday life and record whatever you're seeing in the everyday setting around you. Both eye trackers and all eye trackers work on the same principle. They have a camera and they have an infrared light. Or multiple cameras and multiple infrared lights. So in the desktop version, for example, there are infrared lights under and two cameras in the box that you see here. That's the eye tracker. And in the mobile version, you have two cameras here under the glasses. And on the sides, you have three infrared lights. So the infrared light locates where your pupil is, and the cameras below track the pupil. The benefit of the desktop eye tracker is that you can control where your data is coming from. It's all from the screen. So the eye tracking data can be plotted directly onto the screen. Whereas in the mobile eye tracker, it could be anywhere. So the algorithm itself, while you're collecting data, will not be able to understand where this data is coming from. And there would be a lot more offline analysis required before you can say, data point 1 was me looking at a screen, data point 2 was me looking at the glass of water, data point 3 was me looking at the wall behind. This will get clearer as I speak about what the data looks like. The eye is constantly moving. That's something we need to start with as an assumption. So when the eye is constantly moving, you can have something called microsaccades, which is when the eye is, which would be every data point that the eye tracker takes. So for example, if you have an eye tracker recording at 120 Hertz, then you have 120 data points per second, and each of this can be a microsaccade. But you can also say that if these data points are within certain number of pixels on the screen, and they are within a certain time range, then this can be defined as one fixation. And there are multiple ways to define this. You can define it yourself. You can ask the software you're using to define it, and so on. And when you have fixations, then the points between the fixations are the actual movements of the eyes. So every point which within a certain time frame can be clubbed into one fixation, and between two fixation is the eye movement, and that's a saccade. All eye trackers will also give you parameters for pupil dilation and blink rate. You should be careful here though, because sometimes eye trackers just take all missing data as blinks. So if you have a blink that's a few seconds long, then it's just that your participant just has eyes shut and it's not exactly a blink. But to better understand what this looks like in a paradigm, I have an example here from my own data from one of my experiments, where the participant had to find a target word in a grid below. So the grid had lots of words and they had to find the target in this grid below. And here you're going to see circles as fixations. So circles are all the data points that I've defined belonging to one stationary point, like subjective stationary point, and saccades are the lines that you will see. The bigger the circle that you see, the larger the fixation duration. So here you see one participant looking for the word Esther, and there they found it. And then they look longer to check if that is the correct word. And this is just one participant on one trial, but you see here what I mean by fixations and saccades, and together you can have a trial that lasts a few seconds. And this is just one experiment with one participant. But then what do we analyze in this? So the output that you get can look quite overwhelming if you haven't worked with eye tracking data, or if you don't know what to look for. I mean, sure, it's data points. Most of us are data analysts here. You can put it in, you can run some models, you can calculate some descriptives, but what does that really mean? So if you have raw data, it means it's every time point. So every in a 120 hertz frequency, 120 time points per second. And if you have event data, it means that you've already told your algorithm, this is what I define as a fixation, this is what I define as a saccade, this is what I define as a blink. And then that is your event data. And that can be fixation, saccades, pupil, dilation, blinks, and so on. Further, what you can define is areas of interest. So you can say, I have this grid and I had to look for the word Esther. Now I define Esther as an area of interest. So I define those pixels as an area that I'm interested in on the screen. And these areas of interest don't have to be on the screen. If you're using a mobile tracker, you can say, I define every person as an area of interest. So if I'm looking around the room, objects are one kind of area of interest and people are another kind of area of interest. And then I can distinguish between how I look at people versus how I look at objects. I can also distinguish between when I'm reading something, how each word is an area of interest. Do I go back to the word? Do I have trouble reading? These are very interesting things you can have as biomarkers as well as cognitive biomarkers, particularly in clinical research, how we look at people, how we read, how we interact with the objects around us. And finally, you can have scan path characteristics. So the entire video I showed you of fixations and saccades moving, the circles and the lines connecting them, that together is called a scan path. And once you have the entire scan path, you can analyze if the scan path had more fixations on a certain word, on a certain area, or you can say, so versus scan path 1 to scan path 2, did one scan path, was it longer, was it shorter, did it have more angles, did it start vertically, did it start horizontally? If you just take these lines and circles as one pattern and then take another lines and circles as another pattern, you can compare this in a number of ways. So you also have scan path characteristics that you can analyze. Okay. We can now move on to how we work with eye tracking data and how we analyze it. And here, I hope you followed the first part of the talk well enough, because things are about to get really complicated as we look at multiple participants, multiple trials, and how we link it to cognition. So what I showed you, the video I showed you before, was one participant on one trial. Now, typically in experimental psychology or in any kind of research where you're trying to find a cognitive biomarker, you need to have large number of data sets. So you need to have, for example, in my study or in multiple tasks, we had multiple tasks. Each task had multiple trials. Each trial had a different stimulus, and each group had a number of participants, and I was looking at 4 different groups. So if you're looking at, for example, how children with autism look at social stimuli different from typically developing children, then you need to have at least these 2 groups. And in cognitive research and biomarker research, you need to get more complicated because there are these overlapping comorbid groups as well. And there are disorders that may be similar, may not be similar, or exist together or don't exist together. And you may need to differentiate between all of these individual variables. And so on one level, you have the interstimulus differences. On another level, you have the between participant differences within the same group. And then you have the between group differences. So you have these 3 levels of differences. Again, just to show you how this can complicate quickly enough, think of the parameters we discussed. Think of areas of interest. I'm going to show you the same task again, but now think of the areas of interest we discussed. And if I take the target word as an area of interest and I take the scan path and I want to compare the scan path now across 4 participants, how would we go about doing that? Okay. Sorry. So here we have 4 different participants. I'm going to just play that again. And they start there. And each of them finds the word quite fine. But there's a difference in how they find the word. So the differences in these kind of cognitive variables are quite subtle. If you just look at it, you're like, oh, are there any differences? But now, if you look at the first time they looked at the target word, the time at which they found the word, or the path that they took to find this word, how long did they take? How many fixations did they need? How many saccades did they take? Did they take a route that was quite long, or did they take an effective route that would help them find the word quite soon? Did they waste time looking at words that they did not need to? For example, all the words on the right side, or did they effectively just look at the words that they had to look at, which is the words on the left side? So all of these finer points can influence how we analyze this data on these 3 levels. Sorry. And now, once we find this, how do we link it to cognition? We are ultimately studying humans. So what we're looking at is attention, perception, memory, inter-participant variability. And it's the finer points again, like I discussed in the previous video. So now when I show you the video, try looking at when the participants entered a certain area. How would you measure memory if you removed this? Did they have to like look at the word on top very often, or did they not, which would measure short-term memory or working memory? The variability between participants. If these 4 participants, I were to tell you, are from the same group, then even within the same group of participants, there is a certain amount of variability. And how do we account for that? These are all things that we would have to look at and consider, especially in our cognitive research. So again, now you look at it, you can see when they entered this area of Esther. So the gray one entered before and the green one at the end. And then again, 2 of these colors found the word before the other. And now if you look at the general pattern, you can see the variability. You can also see variability in recurrences. For example, when they go back to the same word, when they move ahead from a certain word. And all of these connect very well to cognitive variables. And that's because eye tracking and in general, the oculomotor system has been really well studied through the last 50-100 years. And we know a lot about its connections to the brain. We know a lot about its connections to cognition. And so it's very easy for us to be like, oh, longer fixation duration is in these disease cases related to longer processing time. And that tells us something about the underlying processing mechanisms that a certain group or certain individual will require, which in turn, again, will help biomarker research. And finally, I want to speak a little bit about using R because, as Lily said, I am a part of Our Ladies Freiburg, and I didn't actually learn programming formally. When I started my PhD like 6 years ago, I had no idea what to do. I am trained in clinical psychology. We had SPSS in our masters, which was really not sufficient for the kind of analysis I was doing in my PhD work. And I slowly but steadily found the R community. And 6-7 years later, still a lot of social and behavioral scientists don't program, but it's starting to change because of R and the welcoming community that it provides for us to be able to learn. And that's something we should really foster. What you see there at the bottom right is our logo from Our Ladies Freiburg. Freiburg is a city at the edge of the Black Forest. So what you see there is the Black Forest in the back and the typical hat with the Black Forest cherries. And my work through Our Ladies Freiburg has also helped me learn a lot, not just about my work, but about topics that I would not normally consider. Like my co-organizer works with geographical data, and I think that's really cool now. And I learned a lot about geographical data. My other co-organizer works with linguistics, and I worked a lot with linguistics now. And not just our ladies, but our community in general, it's well supported, it's open source, free, it's really powerful. With respect to eye tracking, there are lots and lots of packages that you can use just for eye tracking. I didn't have to use these packages because I was trying to be more flexible, but there are packages for area of interest analysis, there are packages for pupil dilation analysis, there are packages to clean data if you're working with infants. Infant research and eye tracking can be really fun, but a mess when it comes to data collection. And there are packages to solve these. And yeah, it's turning out to be the standard for statistical analysis. So, yeah. And we finally go to why. Now I've shown you eye tracking data, and hopefully you're interested enough in the data itself and the kind of cool things it can do, but why should you use it? So those are my three things. You should use eye tracking data because it's easy, flexible, and resourceful for the human data analysis that all of us want to do in the future, particularly with respect to biomarkers, but also in general. So it's easy to operate. It's easy for people to learn. Through the last years, I've trained probably 10 different MDs and students in different fields to operate the entire system, and it works really well. It's easy to administer to vulnerable populations. I work with children and adolescents, all under the age of 15. Some of them with neurodevelopmental disorders, and it was always easy to administer. Like through the years, I've administered eye tracking parameters and really complex parameters to like hundreds of kids with autism, ADHD, or both, and it was easy. And it's easy to infer because we already know the systems, the oculomotor systems that are in place. Second, it's flexible. It's flexible in tasks, so you can have cognitively driven tasks like the ones I showed you, which is a visual search. You can have a free viewing task where you just show an picture and you're just told to look at the picture, don't do anything, admire art, things like that. You can have reading paradigms and you can really see how the eye is moving while you're reading. And you can have real life examples as well. My favorite study for this is from the University of Sussex. The University of Essex, which told their participants, university students, to just go and buy a cup of coffee. And this is something you can do with the mobile eye tracker. You can just be like, go buy a cup of coffee, and we want to see what you're looking at when you do that. In applicability, of course, clinical psychology, where I'm coming from, but also consumer behavior. When you go to a shop and see a new offer, or you want to buy a packet of cereal, how do you do that? Expertise and training, training people for Air Force, for different kind of expertise, like in art. You can use eye tracking for all of these as well. And finally, it's resourceful. You can integrate eye tracking parameters with each other. So you can look at fixation saccades, scan path, pupil dilation, blink rate, microsaccades all together. But you can also have behavioral data. You can have key press response. You can have EEG and fMRI integrations, which also can be analyzed together even in R. You can have activity monitors. So you can have how well somebody slept and how their attention was the next day, for example. You can have how much somebody moves during the day and how their memory performs. So you can have all these different mobile monitors that you can use together.